Bismillahirrahmanirrahim. Assalamu alaikum. My name is Muhammad Asim. I'm working as DevOps engineer. In this video, I will be covering the EKS Karpenter. What are the advantages of EKS Karpenter? What is EKS Karpenter and the deployment of EKS Karpenter. So everything I will be doing through Terraform. So EKS Carpenter is you can say that is a node autoscaler without using the traditional EKS cluster autoscaler. So it is very efficient, and that is something we need with regard to the quick scaling of our EKS cluster. So let's begin. One thing I need to tell you that Karpenter is going to be deployed on the worker nodes, so you should have at least one worker node available because we don't have access to the Kubernetes control plane. So definitely we need to have at least one um worker node up and running. So as I told you in the start of the video that I will be using Terraform, and I've already created modules with regard to that. So first of all, I will be setting up the backend for Terraform S3, and then we are going to use official HashiCorp Terraform module for the VPC, and in that particular VPC, we are going to set up the EKS cluster, and this EKS cluster is also we will be using the HashiCorp Terraform module, and in this cluster we are going to use the managed worker node, and I will try to deploy this particular node as minimum as I can. Then I will be deploying the EKS Carpenter, and everything is going to be in an automated way. So let's begin. So let me first of all navigate to the code section. So I will in fact I've already added the repository, which is the public repository for you guys. You can have the same code and commands available in that particular repository. You have to simply clone it and everything is going to be available. So what I will be doing, let me try to use this bucket. So I have done the testing, I guess 1 hour ago. Let's say if this bucket is still available. So let's see. Yeah, this bucket is available now. I'm going to enable the versioning as well. So these are you can say the prerequisites. This is the backend for Terraform, but these are the prerequisites key pair. This key pair is going to be used by our cluster. So let me show you that. Make sure that this name should be same in your EKS cluster, Terraform Cloud Geeks EKS. So I'm using this name. So if I navigate to the EKS cluster part, so key name is different. So if the key name is different, then you should see a must error in the deployment. So I'm you see updating this part as well. So let me simply make sure that even the spell check, I just want to make sure that everything should be same as it is. So this is the key we need, and this is the PEM key is going to be available. So let me navigate to the AWS console and show you that currently if I navigate to the EC2 section and navigate to the dashboard, we don't have any PEM key available. So click here, EC2 dashboard, navigate to the key pair section. You see zero key pair will be available. So what I will be doing, so let me simply copy this part and I'm going to paste it. So this will create the key pair, and also the .ssh directory if it is not available. So let me check if the key is available or not. Simply click escape here. Now it is available. Navigate to the dashboard section. Just okay, and try to refresh it. You see we have one key pair available, and then we are going to cover the config part, sorry, kube config part. Definitely, if you want to access our cluster through Terraform, everything, as I told you, is going to be automated. So this kube config is going to be automatically updated. So if I get the content of this directory, let me show you that it is going to be a blank one, because Terraform is going to update this kube config. Okay, so previously it was used, but if I do kubectl get nodes hyphen override this cluster, in fact we don't have any cluster, so it will give us an error definitely. So even if I make it a blank, so let me do that as well, so that would be fine as well. And if I do get, you see this file is now blank. So anyway, I'm going to um, create a cluster here. Okay, so let me source this env. What we have this env, if I navigate to this env file, so this is the cluster name, this is the kube config path we are exporting. So okay, so and it is going to be available in this particular shell. So let me, okay, I am in the wrong area. Let me navigate to this Terraform and navigate to the environment and dev. You see that EKS is available, and I'm going to source it. So these environment are variable are going to be available. So this part is done, and now I'm going to cover the Terraform part. But before that, I need to deploy the infrastructure as well. I do Terraform apply, and I'm going to do this auto proof. So the EKS cluster will take about 10 to 15 minutes, I guess, for the complete deployment. So what I will be doing till then, I'm going to give you a demonstration that what are the advantages of Karpenter, how it is going to be deployed through Terraform. There are other tools as well, EKSCTL, in previous videos. With regard to the deployment of EKS cluster, I've used the EKSCTL tool as well, through Terraform as well, how it can be achieved through Terraform, and also we can use the EKSCTL CLI, and that creates the CloudFormation templates. But this tutorial is with regard to the official Terraform module registry, and this tutorial is not limited to the deployment of EKS Karpenter. We are going to see that how we can use the production ready EKS cluster through Terraform in few minutes, and it is going to be official uh, from HashiCorp. And let me navigate to that part. So it is calculating the stuff with regard to the infrastructure, and it will be start deploying the infrastructure in few minutes. So I guess I have initialized the backend. I don't know. Okay, let's see. Okay, so let me start with the VPC section, and then I will be jump to the other part. So the deployment seems to be started, and it is going to do the automation for us. 52 resources are going to be deployed along with the EKS cluster and VPC. In that particular custom VPC, we are going to deploy this cluster, and this is the very important area with regard to the tagging. So I'm going to use the private subnets, and in this private subnets, we are going to deploy our resources, which are EC2 instance as the host for Kubernetes pods. So this tagging is required by EKS Karpenter, and um, if this tagging is absent, Karpenter is not going to work. Anyway, there are other stuff with regard to that, but everything, as I told you, is automated. So you have to just listen or see the video till end, and you have to simply use the Terraform apply command and make changes according to your cluster requirement and other tagging stuff. So as I told you that this is the EKS cluster, I'm going to use this latest official version provided by AWS, and I'm also going to update the kube config. So this is pretty much self-explanatory stuff. So as I told you, we are going to use the private subnets, and let me see if anything which is not that um, okay, everything seems to be okay. So, node group, cluster instance, key name. As I told you, this key name is really important. If this goes wrong, and deployment of this managed node group is not going to be happen. I've added the additional tags. So, what is mean by name? So, name is the launch template. So, as you see, this node group is going to create launch template, and the template name is going to be this one. So the nodes it's going to launch, it has the name tag with EKS workers, and as I discussed, the key name is going to be this one. So we are going to use the on demand. You can use both on demand and spot as well, or spot as well. So it is up to you. So as I told you that I'm going to use this T3 medium node. On this particular node, uh, EKS controller is going to be deployed as I discussed. So that's why we need it. And let's see what is happening at the back end. So the creation of cluster seems to be started. And if I navigate to um, the EC2 section and also navigate to the EKS cluster. Okay, so the cluster creation seems to be started. So okay, it has been started, and also let me show you the other stuff with regard to the um, Karpenter. So EKS cluster autoscaling Karpenter node I'm role. So this role is required by the Karpenter, and excuse me. So AWS managed policy. I mean AWS provided policy with regard to the SSM core. This policy is going to be used by our EKS cluster for scaling and other stuff. So this policy we are attaching with that particular node. Module output is going to be fetching from the above role. So if you have experience with the Terraform, you can easily understand that. Even if you have not, you have to simply clone this repo, navigate to this particular directory, and let me show you that part as well. So where you have to navigate, let me open another workspace, and for instance I'm in my root. So if I navigate to this Terraform, so navigate to the environment dev. If I do ls-a, so simply use the particular command with regard to the control all apply. Okay, I'm going to use this later. Terraform apply. I've used, the Terraform auto proof. You don't need to do that. Do the Terraform plan stuff and see what has going to be deployed. So currently the deployment phase, as I told you, that it will take about 10 to 12 minutes. So I'm going to pause the video, but before that, let me show you the stuff. So it is going to create the EKS cluster node IAM role, and then we are going to set up the Karpenter controller IAM role. This role is going to assume the OIDC OpenID Connect provided by AWS, and the cluster name is going to be fetched from environment variable. In the last section, we will be doing the Karpenter installation, and it is going to be through Helm, and we are going to use the AWS resource um, with the name help, with the name, sorry, um, um, have help. Okay. So guys, I'm really tired. Just bear with me and let me navigate to the Kubernetes, sorry, Karpenter installation. So this is the Helm resource provided by Terraform. What it does that it is going to install this application for us. And this is the repository it will use and the role it needs. We are going to provide it through our modules. So anyway, let me then navigate to the cluster section, and it will take a while. Till then, I guess I should be pausing the video, or if I have to show some other stuff with regard to that managed worker node, and let me till then navigate to the template section. You see, let me show you that part. So currently template is not available because we are not even reached that particular at a particular part of worker nodes. So you will see that one automatic um, template is going to be available with the specific settings we need for our deployment. It is going to be T3 medium and encrypted and EBS optimized, etc. So I guess I'm going to pause the video once everything is going to be available, and I'm going to resume it. So guys, we are pretty much near to the deployment of our EKS cluster, and then the deployment of our nodes are going to be started, and then the deployment of that particular role, Carpenter role, which is going to assume the EKS cluster, sorry, which is going to assume the OIDC, which is going to be created. So node group is still in creation state, and let me show you guys before moving to the other part. So EKS worker seems to be available, and let me navigate to the UI part, and let me simply refresh it. You will see that one template is going to be available. So I've just refresh it. So you see um, template is available, and navigate to the instance section. You will see that the provision, the EC2 node has started provisioning, and let me navigate to the um, shell here, and you will see in a short while the deployment of EKS Karpenter is going to be started, and you excuse me, you will see that if I do the kubectl get pods, you will be able to see that cube CTL is then able to make API calls to EKS cluster. So let it finished, and it will take about, I guess, 3 to 4 minutes maximum. So 2 minutes has already passed. So you see the installation of Karpenter has started. So that is why I was not, pausing the video to give you a demonstration that how that all process is going to be, automatically deployed. So this will take, I mean, 40 to 60 seconds, and let's see. So guys, you see the deployment of this Carpenter has completed successfully, and let me show you that kubectl get nodes. First of all, I want to show you get node hyphen o wide. I will have one node available in my cluster, and it is T3A medium. So if I simply refresh it, and you see it is available excuse me, and it is the managed node. So how you can check that? Simply click this, click the configuration, navigate to the compute section. You see it is now available in the managed node group. So that is it with regard to the deployment of EKS cluster, EKS VPC, Karpenter automated installation. And now then what I will be doing, I will be moving to the last part of our Karpenter. So if you navigate to, let me close this part. So if you navigate to this Karpenter section, in Karpenter section I have added some commands. So first of all, let me show you what we have. If I do kubectl get all in all namespaces, so you should be able to see the Carpenter controller, and we are going to now use the provisioner. So Carpenter as a provisioner, you can use as many provision as you want, but let's see what we have. Okay, I have network issue. Okay, let me, that's why my net is so slow. Okay, okay, just see ping. Okay, let me pause the video, guys. I will be back in a moment. So guys, my net is back. So let me try to show you guys what we have. So if I do kubectl get all in all namespaces, I should be able to see the status of our pods running in different namespaces. As I told you, this is the Karpenter pod and it is running in a specific namespace. With regard to the assume role, let me navigate to the AWS, which I forget it to tell you guys. The assume role, which is going to be, I mean, that particular role is going to assume the OIDC. What is the OIDC? It is the OpenID Connect. So if I navigate to the cluster section, in cluster section configuration, click on the details, you see this is the OIDC and it is going to be automatically available or attach to our identity provider. So if I click the IAM role, you see what is OIDC. I have enabled the OIDC in our main module. So if I navigate to the environment section, navigate to the navigate to the main.tf. So navigate to this EKS cluster section. So this is the OIDC. So I've tagged everything, so you guys should be able to understand how you can enable or disable the stuff. So I've enabled it, and now if I navigate to the identity providers, you should be able to see this is the F83E. This is the cluster ID F83. I'm reading the last four alphabets. Okay, so this is with regard to the OIDC, and on the last part, let me show you guys. If you click it, it will say assign a role, but in fact, the role is going to assume this OIDC. So let me navigate to um, the IAM section again. So let me show you that part as well. So if I navigate to the roles section, you will see the Karpenter role, which is going to be created through Terraform. If you click this guy, and you should be able to see in the trust relation shapes, you will see that is the OIDC, which is going to be assumed automatically by this Terraform code. And if I added the trust relations, I mean shape, you will see that this is the system service account is going to be Karpenter, and the namespace is going to be Karpenter. So everything is automatically done. So we are moving towards the last part of our um, deployment of Karpenter provisioner. So simply navigate to this Karpenter section. In Karpenter section, we have Karpenter provisioner YAML. So first, I'm going to give you a just hint of this file. So this is the provisioner, and we are going to use this as a default. And this uh, is going to be, I mean, label I've set up for the dev team. So you can set up any, provision for different teams and according to your environment. So some of the stuff is commented. I mean, for instance, if you want to just tell Carpenter to use this particular specific nodes or types, it then going to select only these type of nodes. Other than that, I just want to make sure that Carpenter should decide itself what sort of host it needs and what is the type and size. So that is why we are using the fast and efficient Carpenter. So you can use the on-demand and spot as well. I'm using on-demand. This is the top limit I said you can set up according to your requirement, CPU resources, and other than that, um, this is the profile name, and this TTL second after empty, and it is going to, this is the, I guess, I should say the grace period. After 30 seconds it is going to destroy that particular pod, sorry, particular node. So I guess I should be um, also what I will be doing. First of all, let me navigate to um this section. So if I do cd and then if I do cd to Terraform and then move to Karpenter, and I'm going to apply this kubectl apply hyphen f Karpenter provisioner YAML, and I just want to show you the logs, complete logs in this namespace, and in the other namespace I will be showing you the deployment of our application, and that application is actually a simple. I use the Nginx containers. So let it finished and see. Let me check the connectivity. In fact, it is created. So let me do kubectl get all in all namespaces. So it should be capital letter. And also I want to see the logs of this guy as well. So what this command does, it will tell us the log status of this provisioners. So I'm going to use one more namespace here to give you more hint about that. Let it open in that particular namespace. I just want to give you more understanding. So let it open, and hopefully you guys able to see easily. And anyway, what I will be doing, I'm going to simply navigate to this command section. I'm going to create my first deployment of uh, my application. Oops. So let me simply copy paste this command, and this is the part where I just want to show you the scaling stuff. So if I navigate to, I just want to show you guys from the UI, so you guys should have a better understanding as well. So you see, let me show you, we have T3 medium available um, in our EC2 section. This part is I already covered. So let me simply create one replica of my application, and I'm going to deploy this in default namespace. Do kubectl get all in default namespace. So I'm just typing to show you guys that we are going to use the default namespace for our understanding. So what is the behavior? So no resources currently found in our namespace. If I do kubectl get all in all namespaces, you see one pod is up and running. So if I navigate to um, our EC2 section, it is fine. Nothing is provisioned, and also navigate to this particular section. So it is actually continuously looking for the provision. So what I will be doing now, I will be started scaling this guy. So let me scale it to 20 pods. So one is fine. So let me scale this guy to 20 and see what's happened. So what we are now seeing in our EKS Karpenter. So you see my default auto scaling control plane worker node, I set it to T3 medium. So let's see the brain, and it has the decision making power, what sort of host machine it should launch, how much scaling, I mean, how it is going to scale those nodes. So you see in this section, it is going to show us the log, I mean, with regard to that. So let me navigate to UI section as well. So you see what is the different tagging. It has initialized the T3 micro for us. You see my default is set up to T3 medium. As I told you, those are the Nginx pods. So it has itself decide what should be the right size for the deployment of those particular pods. So that is where it is so efficient, and it is going to be launching those other pods. So let me show you what we have in our default namespace, and let me narrow it down to the default uh, namespace. So if I do cube ctl get all in default namespace. Okay, I'm doing a mistake in command. Sorry. I should type the pods. Apologies, my bad. Uh, get pods. I'm missing here. I'm really tired now. Okay, kubectl get. Uh, okay, I should. Okay, the spelling mistake. Sorry, guys. Get pods in default space. I was wondering, I was not able to see anything. You see, so currently some of the pods are in running state, some are in pending state. Let's see what it has decided till now. So let me refresh it. So you see, it has actually initialized four, one, two, three. These are the three, and four micro EC2 host machine for us. So it is actually cost effective, and it is really powerful in a way that it is going to use spread our pod in those host machine. So the demonstration I just want to give you that it is not using the auto scaling. It has the ability and efficiency and the brain to use the the EC2 machine to provision quickly. And you see, if you navigate to the controller log section, I mean this workspace, I've already opened the logs with regard to the controller. So you see, it says waiting for unscheduled pods. So it is still waiting, and it is going to see that our pod should be in running state. So you see, we have only, I guess, two pods remaining. So let it run, and I just then I'm going to show you the scale out as well. So you see, as the load increases, what it does, it has spin up the best EC2 machines for us to host our pods, and it decides itself rather than we, for instance, if we spin up one MX R5 large machine or whatever C5 large, and it is going to cost us. So it is really cost effective as well. You see, it has spin up the right size for us to scale out and scale in. So you guys wondering that why I choose to use one node as well. So in the start of the video, I just covered this part that um, EKS cluster, EKS Karpenter node autoscaler is going to be deployed on this particular node, as we don't have access to the control plane. So that is why we need at least one node. So it is in fact managed node. So if you use that particular repository, it is production ready, and you can easily deploy the stuff with regard to your dev prod infrastructure regarding EKS, and you can use the Karpenter, the best tool for provisioning. So let me navigate to this uh, pod workspace what we have. If we are we able to scale our pods? You see, 20 pods are now up and running. So and we have scaled to um, um, the right size of the EC2 machine quickly. So let me show you the best part. So now our, for instance, online store has no load, and um, let's say let's say we have only load to, in fact I put it to 0. You can use it 1, or you can scale down to 0, but as to 1 as well. But I just want to show you that how efficient it is. And if you have to check the log section as well. uh, you see, this is the other workspace I have opened. So I just want to scale it to 0, and let's see if I navigate to the um, other workspace, and you will see as soon as I use this command, the TTL of 30 second is going to be now in active state, which means that after 30 second, those EC2 machines are going to be destroyed. So in fact, it will tell us that it is going to destroy those machines. You see, deleted node, delete node, as this message is coming with this particular IP. This node is deleted, this node is deleted. So that how fast it is and how efficient it is with regard to the scaling, and you can compare it with GKE. So I guess AWS is far more better. I mean, that is why it is the number one cloud. I should recommend to use the EKS. It has now the required capability to scale out very quickly. So if you navigate to this section, if I simply refresh it, you will see the terminated shutted down nodes. So guys, this is the tutorial with regard to the EKS cluster hands-on with automated deployment through HashiCorp Terraform of EKS cluster, EKS Karpenter. If you like the video, please like, share, and subscribe. And let me simply, before leaving, try to just spin up one replica or scale to one replica. So let's see what we have. So previously, you see, it has cleaned the node with the logs. You can easily see what happened in your node area. And I mean, you just have to clone the repo, just play with it, and you finally decide to use this EKS Karpenter in production. So it is really cool, and as we are using the latest version of this, and I will be adding the link of this repo in my video description link. So okay, deleted node. Okay, one pod is going to be, I guess, it's going to be spin up on this EKS worker. So let me navigate to this area and see. kubectl get pod namespace default. You see. So the age is 68 seconds. So that is it, guys. If you like the video, please like, share, and subscribe the channel, and share this video as much as you can. Thank you very much. Have a nice day.